So for each acid base, label the stronger acid, the stronger base, the weaker acid, and the weaker base. Then predict whether the position of equilibrium lies towards the right or the left. So this, you're going to look at the table and complete these two. Let's move on to the next one. For this one, write the formula for the conjugate base of each acid. What is the conjugate base of H2PO4? Can you tell me? Conjugate base means this must be what? If it's telling you to find the conjugate base, that means this is an acid or base.
I can't remember. For conjugate, I got them confused. I kept going back when I was doing the sapling. Do you add hydrogen or take hydrogen away when it's conjugating a base of an acid?
Right, it's just adding hydrogen or taking hydrogen away, yes. Okay, so H2PO4, if it says conjugate, you need to find the conjugate base of this, then that means this is an acid, right? And then the conjugate base. Because when acid donates proton, then it becomes conjugate base. This is the Bronsted-Lowry theory, right? Is this clear? So that means if to become conjugate base, this has to do what? It has to donate a proton, correct? Okay, yeah, Cynthia, you are right, but do you think there has to be a charge or no? Positive charge? When acid donates, what happens? What did we say? When acid donates a proton, that proton goes away with just a positive charge, and it will leave the negative charge, which is the electron behind. So now tell me, what would be the answer for the conjugate base? Yes. Okay. It is -2. Is it clear? Because that acid goes away with, that hydrogen, that proton goes away with just the proton. There is no electron leaving. The electron stays here. But this, when the hydrogen ion leaves, means when one positive charge, when it's gone, then the number of negative charge will be more there. So, and it's going to be HPO4 with 2 negative charges. So like for, is this, so for, let's look at this one. So what do you think it's going to be like? Yes, it will be H as and negative, just 1. Okay, and then this one, in this case, the only hydrogen it can donate is this one. These hydrogens, they cannot donate. It's monoprotic, because even though it has 3 to 5, 6 hydrogen, because these hydrogens cannot be donated, only this one. Negative, yes, because the hydrogen goes, always remember, when protons turns to becomes conjugate base, losing hydrogen proton means it will have the negative charge of the hydrogen sitting there with it. Okay, now let's go to the one which is down here. Number 3, write the conjugate acid of each base. So conjugate acid means this is base. So base is going to take the proton, right? This gives proton away, this takes proton, yes. So H3O, so 1 hydrogen, it's adding hydrogen. So when it's adding hydrogen with this positive charge, then it will get a positive charge. Let's look at this one. So PO4 with 3 negative charges, what's going to be? How did you get 4 positive there?
I don't know. I just added to it because I was adding a hydrogen, I guess.
Yeah, but when it's a conjugate acid of each base, the base just takes 1 proton. Let me just add this just like over here. So what do you think it's going to be now? It's going to be yes, so 1 hydrogen, so 1 hydrogen and PO4. And from 3 negative, it's going to be 2 negative. And why this is, it is because now it had what, 3 electrons. That means the number of electron is more than protons over here. Number of electron was more than number of proton.
Oh, I thought it was 3. I can't see on my screen that was 3 negative.
Okay, so, and then when 1 more proton comes in, 1 electron will be, we don't count 1 electron because now it has a proton, so that 1 electron is neutralized by that proton, so we'll have 2 more extra. That's good. Which of the following are capable of acting as an procellularic acid? Can you tell me? To be a proton, to be an acid, what does it need? It needs a hydrogen, yes. So all of these with hydrogen, all of that can be an acid, right? Procellularic acid. And which of these are capable of acting as the base? Now, for this, what you need to do. Which one of these can act as a base, procellularic base? For this, it has to have a lone pair. So you need to figure that out, whether it has a lone pair or not, then only. The one over here, which has the positive sign, cannot be a base. So this is not a base, right? So out of this ammonia, does ammonia has a lone pair? We know that ammonia has a lone pair, right? If you look at the structure, this is how the ammonia will look like with HH. And the water will look like, okay, hydrogen, hydrogen. So these means the lone pair. So this is base, this is base. Is this a base? If the carbon is hydrogen, hydrogen, hydrogen with no lone pair, do you think this is a base? No. Okay, so that's how you're going to figure out the rest. So you do need to know the Lewis-Dot structure to figure these out. So you are using everything you have learned until now. Okay, so for the following reaction, label the acid and base in the reactant and the conjugate acid and conjugate base. Let's do one, and the rest you're going to do it. So over here, which one is acid? Hi plus NH3, NH4, and high negative, which gave up hydrogen. So this is what, an acid? If this is an acid, and which one will be its conjugate base? If that's an acid, then when it HI and is it NH4 and HI and NH? Oh. So hydrogen iodide, this is acid. And when it loses electron, when it loses proton, when it donates proton, it becomes this. Yeah, so this is conjugate base. This is one pair. This is ammonia. And when it accepts proton, that becomes conjugate acid. So those are the pair.